So slowly chemistry pulls me out of sleep, mainly stoichiometry. I get to think about my grades and I feel kinda sad, cause it is unpleasant. You know I want standing grades, my friend, you know I wanna be a star. In confusion you find me just in time to tell me what I needed to hear. You said you don't know what you need, you can leave it all to me. Don't you worry about a thing, my friend, let's learn stoichiometry.
We will look at how we can use stoichiometric relationship in balanced chemical equation to determine amounts of substances in some chemical reactions. Often of being produced and consumed, bring molar mass in each element, placed inside the periodic table. Gram over mole you will get the molar mass of the substance from mass divided by the moles of a substance. A common type of stoichiometric relationship is the mole ratio, which relates the amounts in moles of any two substances. In chemical reactions.
We can use mole ratios to calculate the mass of reactant. Here's an equation: diluted form of sodium hydroxide when reacts with diluted form of sulfuric acid yields water molecule and diluted form of sodium sulfate. Probably hard to imagine, so we are going to present you the question and process on the board right now. First thing first, balance the equation. Remember that we have certain mass of first reactant, and we're looking for the mass of the second reactant. Now that we convert the mass of first reactant to moles using the molar mass, and we use the mole ratio to find moles of other reactant.
Finally, convert the moles of the second reactant to mass, and we continue by calculating mass of the product. Just pay attention. You convert the mass of either reactant to moles using the molar mass. You use the first reactant and use the moles ratio to find the moles of the product. Finally, convert moles of the product to mass. Now you know the keys are mass, molar mass, and don't forget the moles. Knowing the geometric relationship also allows us to find the limiting reagent and excess reactant. What's that I hear? Limiting reagent is the reactant will be used up first in chemical reaction if the amounts of two reactants are not stoichiometric amount. It is also the reactant used in common stoichiometric calculation.
Excess reactant is the reactant remains unreacted when the chemical reaction is completed. Back to the equation again. First thing first, balance the equation. Remember that we have certain mass and molar mass of the reactants. Now that we convert the mass of reactant to mole using the molar mass of it, note that by dividing each mole over the coefficient of each reactants result in different values. The smallest value is also known as the smallest coefficient, which differentiates the limiting reagent and excess reactant. Reactant that has smaller moles is the limiting reagent. The reactant that has larger moles is the excess reactant. Now that we convert the mass of the limiting reagent to moles, and we use the mole ratio to find moles of the excess reactant. Now finally convert the moles of the excess reactant to mass. That mass is then the mass of excess reactant that will be consumed during the chemical reaction.
Reduce the consumed mass by the original mass, you'll get the mass of excess reactant that remains unreacted. During the chemical reaction, repeat it again and you'll find the mass of the product being formed. Convert the mass of the limiting reagent to moles. And we use the mole ratio to find moles of the product and convert the mole of the product to mass. You just have to replace the reactant with product and answer is found. And lastly, heading to the percent yield. Percent yield is the percentage of the theoretical yield recovered. The theoretical yield is the stoichiometric amount that will be obtained by chemical calculation if the limiting reagent reacted to give the product. Actual yield is the amount of the product recovered after the chemical reaction. Actual yield will always be smaller than theoretical yield.
Again, first thing first, balance the equation. This time differentiate which reactant is limiting reagent, which is the reactant that has smaller moles. Then convert the mass of the limiting reagent to moles, and we use the mole ratio to find moles of the product. Finally, convert the moles of the product to mass. The result is also known as the theoretical yield. Given the actual yield, you just need to divide actual yield by theoretical yield times 100%, and now you have your percent yield. First thing first, balance the equation, then convert the mass to moles using the molar mass, and we use the mole ratio to find moles of other substance. Finally, convert the moles to mass. That's the conclusion. I hope you understand the lesson now, my friend. Do not you worry.